Hey guys, thought I would share a couple things with you to help you get ready for the Module 1 test. This is kind of a quick review of most of the topics that'll be covered on the test, so that hopefully you are ready. First thing you want to know is a graph a function? The best way to do that is to use what's called the vertical line test. If it touches the graph in more than one spot, it is not a function. So if we look at this first one here, there's nowhere on this graph that I can draw a vertical line where it will touch in more than one spot. Even here, though it kind of looks like it might touch, the graphs never actually touch that line. It's an asymptote. So this is a function because you cannot draw a vertical line that touches in more than one spot. It passes the vertical line test. The second one is a little tricky. So I can draw a vertical line right here, right? And I'm touching in two spots, except this is an open point. So I'm not really touching in two spots. I'm touching here and I'm touching an open circle here where the graph does not truly exist. Same with this spot right here. I've got an open and a closed circle on the same spot. So even though they're on two, they don't both exist at two. So I could say that yes, this would be a function. Now this third one, clearly I'm touching in two different spots. This is not a function, okay? I hope that makes sense. The best way to do a graph to tell if it's a function is to use the vertical line test. You're also going to be asked to give the domain of different kinds of functions, specifically rational functions. You need to know that the domain is all real numbers except for anything that would make the denominator equal to 0. So on this first one, the domain is all real numbers except for positive 5. Because if I put positive 5 in for the x, I'm going to get 5 minus 5, which is going to be 0. On the second one, I'm going to need to factor first to see, well, let's see if I can factor or what values might make that equal to 0. So essentially what you're doing is you're solving a quadratic equation. So I'm going to say 2x squared plus x minus 6 equals 0. And then, let's see, can I factor this? I do 2x and x, and I do 3 and 2, 3x and 4x, so I need positive 4 minus 3. So for this, x cannot be equal to the values of 3 halves or negative 2. So it's all real numbers except positive 3 halves and negative 2. Okay? So you're just solving the denominator to see what would be equal to 0. I can do the same thing on this third one. I have x squared minus 1. I know that this factors to be x plus 1, x minus 1. Therefore, x cannot equal negative 1 or positive 1. The domain then would be all reals except for negative 1 and positive 1. Okay, so with a rational function, the domain is everything except for any value that makes that denominator equal to 0. When you're looking at a square root function, the domain is any value that keeps the radical positive because you cannot square root a negative. The easiest way to do this is to take the radical and just set it equal to 0 and solve. So in this case, 0 gives me a radical of 0. Therefore, this is all values in the domain, would be greater than or equal to 0. That would be the domain for this one, okay? For the next one here, if I say the square root of 8 plus x is equal to 0, and I solve that, I know that x gives negative 8. Therefore, any value larger than negative 8, larger or equal to, because you can square root 0, is going to be the domain. If I put -7 in here, 8 plus -7 is 1, the square root of 1 is 1. I'm good. If I put negative 10, let's say, I'm going to get 8 plus -10 is -2, and the square root of -2 is going to be something imaginary. Therefore, it does not exist in the coordinate plane, so it does not satisfy this function, okay? So my domain is going to be anything greater than or equal to -8 because that's what keeps my radical positive. Same thing with this last one. I'm going to say the square root of -3x equals 0. So if -3x equals 0, then x equals 0 as well. So this is another one where anything larger than 0 or equal to 0 is going to keep my radical positive. Range is similar to domain. Range of a linear function. So any linear function where x has no exponent. So 3x plus 5 or x minus 2 or 1/2 x plus 14. Anything like that is linear. The range is just going to be all real numbers. A square root function is going to be all of the positive real numbers. And then a quadratic is going to be determined by the vertex. So this first one here, the range is going to be all positive real numbers. And think back to, we just figured out that the domain is 0, right? So if I put in 0 here for x, I get 6. That means that the range is going to be anything greater than or equal to 6. This kind of goes back to our transformations. Remember that when you're adding or subtracting outside of the parentheses, radical, whatever, it moves the graph up and down. This graph would be moved up 6. Therefore, my bottommost point or my local minimum is going to be positive 6. So my range is going to be anything greater than 6 on this one. Now the second one here, I have a square root. Remember before I said my domain would be anything greater than -8. That's going to give me a square root value of anything greater than or equal to 0. So my range here is going to be greater than or equal to 0. So with square roots, the easiest thing to do, at least I think, is to find the domain first and then just plug that value in. That will be the bottom of your range. The range will be anything above that, above what you get when you plug the domain value in. That's what I find to be pretty easy. If you have another way that works better, go for it. Now, when we're talking about quadratics, so when there's a squared, the vertex determines that. Remember, the vertex is always either the highest or lowest point. You don't really want to take the time to graph this, but if you can remember that, again, adding or subtracting outside the squared, whether it's in parentheses or just a squared, moves the graph up and down. It moves the vertex up and down. So this first one here, your range is just going to be any number that's bigger, greater than or equal to 7. Your parent graph is x squared. By adding 7, you move the graph up 7. Therefore, the vertex is going to be at 7 and go up from there. The second one, your range is going to be greater than or equal to -4. Because this moves the vertex down 4, therefore my range is going to be higher than that. Now, the one thing I would caution you, be careful if there's a negative in front of the squared. So let's say I had something like f of x is equal to -x squared plus 5. 5, because this is going to be flipped, if you were to graph it, it would be upside down. Therefore, 5 is going to be your highest value. So your range would actually be everything less than or equal to, positive 5. Okay? So kind of just pay attention to that one thing. If there's a negative in front, remember that it flips it. Same with the square roots, actually. If there's a negative in front, it flips it. So your range now becomes your highest value and underneath. So you're basically flipping that sign. okay? When you're looking at graphs, one of the things you need to be able to know is when is it increasing or decreasing and for what values. They use the turning point to determine that. So if I look at my graph here, let me get it so you can see. I can see that I have a turning point right here where x is 1. That is going to change from either increasing to decreasing or decreasing to increasing. In this case, it's changing from decreasing. So on the left-hand side here, as I'm coming into the graph, I guess, I'm decreasing. So I would say this is decreasing for every value to the left of 1, or for x is less than 1, and it is increasing for every value to the right of 1 or greater than 1. Okay? And I guess since the graph exists at that point, we should probably use our equal to's as well. So just kind of pay attention to that. Remember that it's from left to right. I always kind of want to say it's increasing to the left because I'm thinking it's moving to the left, but it's not. You're coming in and you're decreasing because you start at 4 and you're heading down to -2. So you're decreasing for all the x values that are left of or less than 1. And then you are increasing once you get to that point at 1, -2, you are now increasing to get back up to 2.1 or whatever, up to 6. Okay? Another thing you need to pay attention to our local minimum and local maximum. Remember that those are points on the graph, so the arrows do not determine that. And look at the turning points. Those are going to be your maximum and minimum. So this first one has one of each. It's going to have a local maximum at 2.4-ish, 2.4-ish, and it's going to have a minimum at, let's call it -2.2, -5.1, something like that, okay? I know they'll give you nicer points than these graphs. These are kind of ugly, but your local maximum is always the highest curve. I don't want to call it a vertex, but turning point on the graph. Your local minimum is always the lowest one. This second one has a local maximum at whatever that is, 0.59-ish. It does not have a local minimum. So there's no minimum here, okay? The third one clearly has a local minimum right here. It's the lowest point on the graph. Now notice, remember, we're not including the sides. I know it goes lower to the right and it goes lower to the left, but we're talking about a local minimum, so that's the lowest. Peak or valley, how about that? Peak or valley that's on there. It's the lowest valley. So this would be your minimum. You have 2 peaks. The local maximum is the highest one. So it's this one over here. Okay? The one on the right here at like almost 3 is neither. It's not a maximum, it's not a minimum, it's just a turning point. So make sure you're paying attention to which is which. Pay attention to, especially when they give you multiple choice, sometimes they switch them. So like this first one here, they might say you have a local maximum at -2, -5, and a local minimum at 2.4. Pay attention to the words when you're reading those multiple choices, because they like to switch them up on you to be tricky, okay? All right, even or odd function, how do you know? So you always just plug in -x and you simplify it. If you get what you started with and all the signs are the same, it's an even function. If you get the opposite of what you started with, so all the signs are switched around, it's an odd function, okay? So start by plugging in -x into the original function. So for this one, I'm going to put in -x for my positive x, and then I'm just going to simplify. -x squared is -x times -x, which is positive x squared. I have exactly what I started with, so this has to be even. Same thing for the second one. I'm going to plug in a negative x for both x's, and I'm going to simplify and see what I get. So negative x cubed is negative x times negative x times negative x, which is negative x cubed. When I multiply that by 2, I have negative 2x cubed. Did everyone follow me on that? So you're taking negative x times negative x times negative x, which is negative x cubed, times that 2 that's in front becomes the negative 2x cubed. And then negative 4 times negative x is plus 4x. You can see I have the exact opposite of what I started with. Both of my signs have changed, so this has to be odd. Now, if you get it where one of the signs is changed, but one is not, or two of them are, two of them are not, whatever, then it's neither. Okay, so either the signs are all exactly the same or the signs are all exactly the opposite. That tells you even or odd. If it's not one of those two, then it's a neither. Kind of a helpful hint, look at the exponents. If you have even exponents, it's pretty much going to be an even function. Like if I look back at that last one, I'm going to flip here. Notice that I had a squared and I had a 0. Those are both even exponents. I have an even function. Remember, x, just plain old x, has an exponent of 1, which is odd, and a constant has an exponent of 0, which is even. So that can generally be a helpful hint. If you have a mixture of even and odd function, or even and odd exponents, it's generally going to be a neither, because some of the signs will change and some won't. So just kind of keep that little helpful hint in the back of your head. You still want to plug it in and check just to be sure. But generally, as a rule, all even exponents are an even function, all odd exponents are an odd function, and a mixture of exponents is going to be a neither, okay? All right, some function operations. You'll be given two functions. You'll be asked to add or subtract or multiply or divide. You just do that. It's combining like terms. So in this first one here, I would take my f function, which is 3x squared plus 5, add it to my g function, which is 2x, and combine like terms. I don't actually have any like terms here, so I'm just going to write it out. 3x squared plus 2x plus 5, okay? Same with subtracting. I'm going to take my f function and I'm going to subtract my g function. Pay attention, especially to subtraction. Make sure you're doing them in the right order because g minus f is not the same thing as f minus g, okay? So be really careful about that. But again, I don't actually have any like terms, so I'm just going to write it out in descending order. 3x squared minus 2x plus 5. Done. Most of the time you'll have terms that you can combine. Just so happens on this one I didn't. Now when I'm multiplying, I'm going to take my f function and I'm going to multiply by my g function. This is where sometimes, depending on what your two functions are, that box comes in kind of handy. You don't necessarily need it in this one because it's just distributing. But remember this guy, and you multiply the pieces. Again, generally you have more parts, but it kind of helps you keep your pieces together. So this would be 6x cubed plus 10x. Remember that when we have like a binomial and a binomial or a trinomial, the box can help you keep your pieces in order and combine your like terms correctly. Now when you're dividing, you're simply going to take the f function divided by the g function. I would say 95 times out of 100, you're not going to be able to simplify. But there might be those couple times where you can actually factor and simplify. If you're not factoring, you're probably not simplifying, okay? Like I can't take an x out of both of these because I don't have an x with the 5. So remember that when you have a rational fraction, which is where a variable is in the denominator, unless you can factor something out of every single term, you cannot simplify it, okay? Be really careful about that one for division. The other thing you're going to need to do is find some composite functions. So finding one function inside of another function. So remember that you always start from the inside and work your way out. So this first one is telling me to take the g function and put it into the f function. So I'm going to take the f function, but I'm going to replace my x with my g. So notice I took the x out and I put in 2x instead. Now I'm just going to simplify the thing. So when I square 2x, I get 4x squared. I'm going to multiply that by 3. I can't add 5, so my answer is just 12x squared plus 5. I'm done. Now the second one here looks the same, right? But it's not, because this is telling me to take the f function and put it into the g function. So I'm going to take this whole f function and I'm going to put it in for the x in the g function. So I'm going to take 2 times 3x squared plus 5. And again, I'm going to simplify. This one's pretty easy because I just have to distribute the 2, and I get 6x squared plus 10. Done. Okay? So be really careful with your composite functions. Make sure you're taking the innermost one and putting it into the outermost one. Sometimes, I haven't really seen it, sometimes they write it like f of g of x. It means the same thing. You take the second one and you put it into the first one. But as a general rule, they seem to be writing it with multiple parentheses. So take one that's inside the most, put it into the outer one. Finding the inverse is another thing that we need to be able to do, and that is sort of those different steps that we go through. So first step is always replace the f of x with y, then switch your x and y. Okay, once you've done that, just solve the function to get y by itself. So in this case, I'm going to add 9, and I'm going to divide by 7. Last step is to put in the f negative 1 of x, replace that with the y, just so that it's written correctly in function notation. Okay. Same thing on the second one. I'm going to rewrite this using y. I'm going to switch x and y, and then I'm going to solve to get y by itself. So I'm going to subtract 9. Remember that when I have a squared, it means that I'm going to square root the other side. And then lastly, I'm going to replace y with my function notation so that this is written correctly. Okay. So finding the inverse, just follow those same steps every time. Here we have to do it with a square root. So again, I'm going to stick in the y. I'm going to switch on. And then to get rid of a square root, I want to square the other side. So I have x squared equals y minus 5. Now I'm going to add 5 to the x squared. And I'm going to rewrite in my function notation. On the last one, I have this x cubed. I'm going to solve it the same way, or rewrite it, I guess. I'm going to start by putting in my y. I'm going to switch my x and y. Then I'm going to try to get y by itself. Remember, to undo a cubed, I need to cube root the other side. So y is going to equal the cube root of x plus 6. And then my last step is to rewrite with the correct function notation. Okay. So finding the inverse, I hope that makes sense for you. You can just follow those same steps every time. Put in the y, switch the x and y, solve to get y by itself, and then rewrite it with the inverse function notation. When you are talking about transformations, these rules are kind of helpful just to know how the graph is moving. So when I'm adding or subtracting outside the parentheses, the square root, the absolute value, the whatever, I am going to be moving the graph up or down. When I'm adding or subtracting inside the parentheses, the square root, the absolute value, inside a container of some sort, if you will, I'm moving the graph left and right. Remember that left and right is always opposite. So plus means left, minus means right. Try to remember that. And then if I have a negative, I'm flipping. So negative flips it up or down. A negative inside the parentheses flips it right to left. So across the y-axis, okay? The one thing they didn't put in here, but that I would also include is multiplying. When you multiply by a number outside of the parentheses, let's say you have f of a of x, that stretches or shrinks the graph vertically. And if you multiply by something inside the parentheses, that stretches or shrinks the graph horizontally, okay? So widens or skinnies it, I guess is a good way of saying it. And then outside either stretches or shrinks. So that's another one to kind of be aware of, all right? So I hope that all makes sense for you. If you have any other questions or need any help with anything else, please be sure to let me know, and I am happy to go over any more things with you or give you more extra problems to help you prepare. There is that practice test that you're going to be doing before you take the actual test. So when you get done with 1.05, then you do 1.06, which is the practice test. Then you can do 1.07, which is the actual test, and then 1.08, which is like a discussion slash reflection of how you did, okay? I'm trying to keep up on the grading and everything, so hopefully you've got an accurate idea of where you're at. Again, if you have any questions or need help with anything, need extra problems, need an explanation, I am happy to help you as much as I can. Just shoot me an email and let me know, all right? Best of luck to you guys. I'll be in contact later this week with more information.